Okay, so basically let's do a quick recap. We are storing, let's say we have taken a number x, which is storing the number, and we have found out log base 2 of the number, and we have found out that it basically represents the bit representation of the number. Okay, but why is the bit representation useful? Let's talk about that and that infamous line of code, which is int I equal to star int star and x. What is the purpose of this line? Okay, now if we had the bit representation of the original number, and we can easily do manipulations on it, but the original number is what? It is a float number. This thing is a float, and I cannot do any manipulations on it. The C compiler doesn't allow you to do manipulations. We have to first convert it into an integer format to do manipulations. But think for a second, if we do directly this thing, let's say if the number x was this and I typecasted it, what would I get? I would be equal to what? 85. We are losing values. This is not how it should work, right? So to get that, this is what's stored as a float star. This address is a float pointer, right? Let's say 0x3f3dc, something like this. Okay, now what we want to do is we want to trick the compiler into thinking that this address is an integer address. So we are going to typecast the address from a float to an int star, not typecast the number. We are going to typecast the address from a float to an int star. And then if we dereference it, we get the original number just in integer format. So this is also an integer. This also has 32 bits. So the 32 bits of the float, the exponent matrix, everything will be directly mapped into the integer. And this can be done how? By taking the address of x, typecasting it to int star, and then dereferencing it. That is how this entire thing is done. This is extremely beautiful, and like and why does this work? Even this is like the side effect of the compiler. Like the compiler wasn't designed to do this. Most people didn't know of this before it was done in 1977 or 86, something like that, by the person who wrote this code. And this is such an interesting thing to happen, right? Now we can, since this I is an integer number, we can easily do bit manipulations on it. And how this bit manipulations will be useful, we'll see in the next part.